I've been reading a lot of books about Kubernetes. There's lots of books about Kubernetes. Especially like DNS, like core DNS and like networking stuff. It's just like so like I feel like I'll understand quantum computing first before I understand like basic how DNS works. But uh, have I read any good like fiction books recently? Honestly, I don't know. I'd have to look at my like Goodreads. I'm going to no, I mean, I've never had a single computer science class in my life. Um, that's why I'm doing this stream so I can learn. Yeah, so I mean, like, there's just like a bunch of stuff I just don't know, and I like I want to learn it all. And like, networking is just, um, I would say it's like complicated. And like, there's a difference between complicated and complex. It's complex, and so the complexity can like kind of catch up to you pretty fast. Uh, so like, well, here let's go to um, I don't know if Python. Um, you Okay, so we're in Python, import this, right? You seen this before? Okay. Yeah, it's buried because no, this is the whole screen. I just haven't pulled it up really heavily. Um, real quick, I'm gonna go and grab the link to the stream so we can sort of share it out, I guess. Do, 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 do. Yeah, so the difference between, well, let me put that back up, I guess. Simple simple is better than complex. Complex is better than complicated. So um, think of it like this: a system. Let's say you have like a graph, right? You've got a graph of some, of whatever. Like let's say the nodes represent people and the edges represent, um, you some relation. Yeah, it's a social network, right? Exactly. Yeah, I know I'm taking 20 minutes to come over the word social network, right? So you like social network, right? So it's so if we took the social network of like the people in this room, it's very simple, right? It's you, me, and we know each other. And that's that. There's zero viewers, so it's great. It's simple. uh, now we add in somebody that if we add in somebody that we both know, it's still pretty simple, right? And then now we start adding, but now we say like, okay, let's go and add in our siblings, right? And I've never met your brother. You've never met my brother. Like I know we both know that we have brothers, but and then so they're like, okay, then add in people. It's like now we start adding everyone we know. It's not complicated, right? In the sense that like I understand. Like if I looked at that graph, I would say, oh, this is just a graph of Addy and Nim and the people they know, right? Uh, and even if we said like the second order of like all the people that we know and the people that they know, right? But it's complex, right? It's not simple anymore. It's right. It's like, but it's something that's built up of very simple bits, right? Any like two-person subgraph is like very like, oh, these are just two people that know each other, right? Um, or like for the context of code, it's like if you start with like very simple, well-defined building blocks, and then you build a lot of stuff, it can become very complex. But it's because it's like doing a lot of things and there's a lot of interactions. not because like the code itself is like kind of think of like obfuscated almost, right? Where like if you wrote code that was like really just kind of poorly organized, it actually might be less interesting and powerful, like what it's actually doing, than complicated code, or sorry, complex code. But because it's like so complicated, like think of it like if you're like you have a function that's like adding two numbers, but then inside of that function, instead of just saying like a return a plus b, you're like, okay, I'm going to take a and store that in a database somewhere, and I'm going to take b and I'm going to put that in like a Redis cache, and then I'm going to start a background process, and that background process is going to go get a from the database, get b from the cache, um, and then instead of just adding them directly, it's going to like uh, multiply them together. It's like yeah, so you're like you end up doing like 50,000 things. Just so that's like a complicated system, right? And like when you're so yeah, that's the main difference. No, I'd say like complex is sort of like necessary. The minimal required complicated, right? Yeah, yeah, yeah. Sure. I think Einstein said, dude, we're 5 minutes in recording Einstein. Pretty pretentious. Um, we, oh my god, dude. Oh my god. No, we're done, and that was our last one. I was gonna say, yeah. So Einstein said something like, everything should be as simple as possible, but no simpler, right? So it's like kind of reverse of that. Okay, I just tweeted this out. Okay, here we go. Okay. Let me stop being distracted by Twitter now. Okay, great. So, oh no. So, here's what we're gonna work on. We talked about this beforehand, but um, I forgot we discussed this yesterday. We're gonna start an app. We're making an app from scratch. Yeah. Okay. And we're gonna do it in Rust. Why are we gonna do it in Rust? Because yeah, you understand it. Um, and we neither of us really know it very well, so it'll be fun. But I think it'll be interesting. It'll be interesting to do. So here's my idea, right? I joke that this is like a startup, but I don't know if it is. It's at least fun to try. Um, there's like a problem in academia in general, whereby it's really hard to reproduce papers, right? Um, some fields are better than others. Like some fields probably lend themselves to better reproducibility than others. So like the very hard sciences, physics, you're collecting like let's say you're doing like higher energy physics. You have a ton of data, like really well put together data, very granular data. That's probably it's like hard to do that. It's hard to like work on petabytes of data, I guess, but it's easier to replicate. You have the data, um, and it's pretty hard facts data, right? As opposed to say, the kind of opposite end of the spectrum would be the social sciences. You know, Psychology is a good one, right? Where you're studying the brain, not really studying the brain like by measuring it, but you're studying people's emotions and you're studying people's affect and that sort of thing. There's a lot of good tools to kind of measure those things, but there's still, um, it's still, yeah, yeah, yeah. Yeah, I mean, so there's like, I mean, there's a reproducibility of like if you have the same data set, you can reproduce the same results. That's one thing. The other question is like, if you like ran this experiment twice, would you get the same thing? You know, if I uh, if I asked you if I asked you today a question about your affect, you know, your or, you know your kind of mental self assessment or something like, it might be very different than an hour from now. Maybe because things have changed, but maybe you just like think about the question differently. There's a whole bunch of stuff there. So it's like, you know, it's there's like a lot of reproducibility. Not, I would say issues, but there's a lot of things to think about with reproducibility. I think, but the to me the hardest problem is not that part of like, you know, if we ran this experiment twice, we get different results, or is like the measurement kind of off. It's in that like, I think I'm not going to pick on any particular um, field. It's kind of across the board. There's oftentimes results that just aren't reproducible, even if the data is, you know, even if the data is solid for a variety of reasons. Um, and then there's another thing where even if a result is reproducible, there's no good guarantee that something is going to be reproduced, right? There's probably, you know, there's probably like a million different articles that come out every day from scientific papers across the world, right? How many of them? There's just too many to for somebody to sit down and just say like, okay, let me run the numbers again and see if this is legit. And I've always thought like there should just be a machine that does that, right? Um, Pick a field with biology, neurophysics, uh, education psychology is a big one. You know, like any field where like would be nice to be able to like crunch these numbers after you see the paper, um, and give it like a score and say, yeah, this, well, you know, not necessarily like decide whether or not the theory is good or the math is good or whatever, right? To say like, hey, I ran this again and I got the same results, so this is whatever conclusions were reached in this paper are, you know, I'm not gonna say like they're good, but you know, like you wouldn't throw them out necessarily. Does that make sense? Yeah, exactly. 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 Yeah. Yeah. So, like I said, I've had this idea. You know, it's like an idea that came to me a while ago, and I dismissed it because even even 2 3 years ago, I mean, to be fair, this is still probably, I'm not saying an impossible problem. It's a hard problem, but that's why it would be fun to chew on. Um, right? Like we're just having fun here, so um, it's an interesting problem. I think it's probably an important problem to at least take a stab at. 2 years ago, so even now, but yeah, even now, it's probably still on the on the like intractable side, but probably close enough to try. 2 years ago, you know, when I probably had this idea probably 7 8 years ago, and that at that point it was like this is just not possible. Even a couple years ago, I'd say this is not possible. Now it's, you know, maybe possible. It was still like, but I think like the biggest hurdles now would just be like scaling it, right? If you really wanted to say like, obviously we wouldn't pick. We just wouldn't have. There runs into all kinds of right access issues. So a lot of papers are just going to be behind the paywalls. They're going to be published in journals that aren't open, right? And I don't want to get into like day one trying to randomly scrape private journals, but there's a lot of open access. Like so we'd say like pick open access journals where we could legitimately pull data in and use them, talk about them on stream. But even that's a big scale. So, but less of a problem, I think, is what you're describing of building a general machine across domains to say like, okay, I'm going to take some right like I'm without any manual human intervention, I'm going to take a paper from um, a behavioral psychology journal. I'm going to take a paper from um, a labor economics journal, and I'm going to take a paper from archive, a new ML deep learning paper, and so those are going to have just very different structures. Like the paper itself, it's going to have different kinds of data, et cetera, et cetera. That was the hard part, and that still is pretty hard. But I think a lot of that glue you can do with some prompts and some AI, um, and even things like charts, right? So like the kind of off the shelf foundational vision models are getting to the point where I mean this better than anybody, not better than anybody, but you spent some time messing around with these kind of multimodal models, right? And they're getting better and better all the time. And so you could say like scan this paper and check out if there's a bar chart. Tell me if it kind of jives with what they're talking about. Does this bar chart make sense, right? You could ask about images. You can ask about the text. Um, and so then it's sort of just getting everything into a consistent format. Um, and then the question is like, what does that score look like, right? So what does it mean to be reproducible, right? So probably um, the best version of like the most reproducible would be something where you publish um, you publish your results in GitHub with the code, with the data. It's all in version control, and then the paper is structured in a way, right, where it's even like not using PDF. Like if you had a non-PDF version, LaTeX or something, or HTML, so like something that was just plain text that you could parse, right? These are I don't know. So that would be the most reproducible, and then having something. So basically, like maybe code generation, where you say, so that would be, I mean, that would be the best, right? If you say, if the code lived next to the data, and then there's an explanation of how this works, you could say to a machine, hey, read this paper, read the code, and try, yeah, like download it and run it on this data, and tell me if, online, find the conclusion where they say, our conclusion is that we got 0.715, whatever, rerun it. Do you get 0.715 or something close to that, right? Um, Now that's the best. Even then, that best case is like kind of a lot of work, but um, we could start there and then work our way up towards. I guess the harder it gets, maybe in some sense, the harder it gets. Like, if that's easy and we got and like it nails it, we could say, not only is this, not only does this paper seem very reproducible, it's been reproduced, right? So there's that problem too of like, hey, they made this code available, they made the data available. When I reran it, I got wildly different results. It's like they showed the work, but the work was crap. Versus like they showed the work and the work seems fine. And then there's the other kind of in that matrix. There's like they didn't show the work, but the work is actually great. It's just like they didn't show it. That's like that's just as bad as it being bad. It's like, yeah, to me that's like the problem with science is if it's not reproducible, you might have amazing results, but then if I can't know, then what does it matter, right? Um, so that's a bad thing. And then the worst case is like it's a really bad result that's not reproducible, right? Um, yeah, 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 yeah. Um, so I think so. Let's do. So let's get started. Let's do first thing we need to do. This is our new app, our new startup, our new whatever, our new little project. What are we calling this thing? Nah, nah, that does not vibe, bro. You can't say GPT. There's something I don't know. There's something I think. I mean, AI is awesome, but if you have to say AI, it's like kind of not as cool as just being like, oh yeah, we got AI, no worries, no big deal. Yeah. Let's ask the AI. Come up with a good name for our startup that where we are trying to test how reproducible science academic academic papers are. It should be playful and fun. Paper Trail Repro Dynamics. Paper Trail Repro Dynamics. What do you think about that? It's a it's like the dorkiest name, but I kind of like it. Let me ask around. Hey, if I was gonna start a company and I named it Paper Trail Repro Dynamics, would that sound cool? Okay. Okay, my wife is yelling at me because I even suggested that. I'm on YouTube, so stop yelling at me, please. I'm on YouTube, so you gotta stop yelling at me. I'm on YouTube. Stop yelling at me. What about just Paper Trail? I lost Nim. Yo, sorry. I think I lost you for like a good 2 minutes. Paper Trail does kind of sound cool, right? Just Paper Trail. Yeah, Paper Trail. Oh, dude. You know what's cool about Paper Trail too? Paper Trail has the letters AI in it too. Mm, yeah, it's subtle. Like it's in there. Paper Trail, it's in there. Okay, that's it. Cargo new Paper Trail. Okay, CD into Paper Trail. Okay, so we now like officially have a Rust project. Yeah. So we do cargo run. Hello world. Cool. And here we go. We got our stuff here. So what do we need to do? We need let me go grab a paper here. I literally one step ahead of you, bro. Yeah. So let me share. Let me share that screen real quick. Window capture. Oh, new window capture. Window capture. Add source. Add source. Nope, that's not it. Add a new source. There we go. Call this. Yeah, it's like. Why is this like so? Sorry, I'll share. I'll. There we go. I'll share with you on the collab can. On the collab can. You should be able to see it now. Okay. Okay. Um, do you want to explain this to people? Well, we're recording it, so people might come by later. People might come by later. Good. Hmm. Yeah. Um, I mean, it's literally the T in GPT, right? So, um, and this is like the classic. This is the classic sort of visual here. So this is a good case of like having a good vision model to like say explain this to me or something, right? Um, but yeah, so the big breakthrough here was the right. Yeah, and I think this particular attention head, the one that feeds from the input to the output, was like, yeah. So yeah, to your point, there's like a lot of pieces like in the ether that stacking them together into the multi-head attention, and um, Yeah, I mean, because you're basically like learning different like sub concepts, I guess, right? Um, right. Yeah, it's like I mean with the CNN, it's I don't know a ton about vision models honestly, so I'm gonna butcher it, but maybe I'm wrong. But my understanding with like a CNN and or like just like convolution models that have convolutions is like each sort of like convolution pooling whatever like those like sub kind of building blocks like each one of those so like the more you stack them sort of sequentially is like step one is step one you haven't seen any data you're on the first like layer of this big network and like the first thing you're gonna like the first pass you're gonna learn basically like you're gonna go from being like blind like seeing absolutely nothing to seeing really vague shapes like like 1%. Yeah, so then like so you learn and then you kind of quickly learn like okay here's like what a circle looks like versus a square and then every one you get like finer and finer um but it's like more of like a sequential thing maybe uh yeah uh, whereas like the whereas I think that like with the attention parallel wise is better I think right. Mhm. Either way, one, I need to reread this paper again because it's just like it's solid, and two, so like by itself, so this makes me think of an important caveat here is look at all the references, right? So um, references are probably really important as well in the sense that um, so what I say is like I don't know. Um, so it's pretty solid. I like it doesn't in just this paper. It doesn't say. Does it say where the code is exactly? Um, yeah. Okay. So they have like they reference the not the code but the data, right? So they're referencing like what data sets they've used, right? So you could go and get the data. Um, I don't know. I mean, at the time when this came out, I don't think it was super common to like publish the like publish like a Python library at the same time as the paper. That's become more common. That said, like this transformer, like you can find the transformer code. I mean it's popular enough. So the problem. So my point is like if this was 2000, when did this come out? 2017. 2017, yeah, 2017. Um, in 2017, if you read this, you would say I don't know, like a 7 or 8, like pretty high. But then it's oh wait, I'm sorry. They do have it. Is that what that is? I didn't even realize they have this code here. The code we use to train and evaluate our models is really okay. So you know what? I take that back. This is probably 9 out of 10. Right? We could basically pull this and say, oh, there's a code base. We could even link to it pretty directly, and then like crawl through here and say, how would I run this, and then actually run it. This might be a really good. This might be a really good example. What do you think? Yeah. Mhm. Yeah, this paper drop. Yeah, good. Yeah, yeah. No, that's fair, but that's also good, right? Because like this will be our happiest path, right? If we can get it to work for this one, that's if we can't get it to work for this one, then this project probably just sucks, right? Yeah, yeah. So let's make um, gotta start some. Okay, so can download a paper. So I'm gonna say let URL equals. Oh, statically typed, absolutely. But as type inference. So yeah, pretty strong type inference. So like we say like this is a string. Um, let's say yeah, I like this. By the way, I'm using a tool called Super Maven. This is like a really nice kind of co-pilot. I should probably turn it off so we can just like learn Rust as we go. But um, yeah, it's like super fast. What for one, it's super fast, right? So uh, like this is there's like no pause, you know. Like I can just kind of like the results are pretty good. I don't want to like it's almost in some sense like too fast because like you almost want to like have it suggest something and like I don't know be able to turn it off. I guess I could turn off Lucy like super Maven stop. Here we go. Or super Maven toggle. So super Maven toggle. All right, we'll do this like let's see. So we want to say um, paper dot contents No, that's we have to build that ourselves. I, I'm writing the this is test driven development, my friend. I'm doing it. So we wrote the test. Um, so like okay, the first thing we need to be able to do is say if I give you a link to PDF, uh, and we'll just start with PDFs. That seems like the sensible place to start. I have a PDF or URL to a PDF. I pass it into this paper object, this paper struct. So we'll go into here. Okay, we're going to main. I guess actually we'll go into like source. We'll create a lib.rs. Okay, and they'll make a thing called so the struct by public struct paper, right? We'll have something probably called pub struct. Good. Oh wait, I'm gonna fix that. Well, you can see the whole thing right now, right? Okay. If you're thinking that I have like anything up the top row, like I don't have any bars or anything. Let me show me the screenshot. Just like dump into Discord or something. So I'm using a terminal called WesTerm, and I basically there's like no bars or anything. It's like totally. Oh, only yeah, because there's like some like hover over thing. I got you. I got you. Um, yeah. What if this shows up on the stream itself? Let me see. Okay, for what it's worth, it's not showing up on the stream, so our lovely viewers won't have to suffer like you have to suffer. But what I can do is I can just shift it down here. Um, okay, so we'll have a paper struct. Okay, we'll have an ID. I guess it could be a string. Leave that for now. So like downloaded at okay, I like datetime etc. I say like created at you know what, I like most of these things. Let's see. Um, okay, so we're gonna pull in we're pulling the datetime UTC stuff from the Chrono library, which is nice Rust datetime library. Downloaded at, created at, updated at. Done these. Okay, so title, body, um, body. I guess we'll come back to, and then we'll say like have like tags. Maybe like domain is. Say domain is a string. Domain could also be struct domain. Um, uh, No, no. I assume at some point we're gonna have one, but we don't have to now. Yeah. So like, no, uh, no. So like, you can for like importing stuff. Um, oh yeah, headers. No, no, that's not headers. Uh, so like, you can like import stuff like from either like third party crates like that you install or from your own like um, from your own crate. But this is like the use. So this is the yeah, the yeah, yeah. So that's our cargo toml. So exactly. So it uses toml, but yeah, same idea. So this is the name. This will be the name of our project, but also like the binary version. This is the addition of Rust. Um, and then so we can do things like cargo. So we'll do like cargo add chrono. That's like the daytime libraries, right? So now that'll install. You can do different. There's like different kind of like these are equivalent to like in Python how you can do like pip install, TensorFlow, GPU, like have like kind of options. So these are like different kind of optional dependencies. Um, and if we go back into cargo, you'll see cool we got chrono. Um, so another one we'll probably want to use. Uh, so here's a couple of cool ones. So cargo air, sorry, cargo add air. So this is for like nice, um, kind of like nice air, like air. So one of the things that so let's try to at this point try to uh, compile our code. It's going to fall apart, but let's take a look at it. So it's going to install all of our dependencies. Awesome. Okay, so actually broke less than I was expecting. Um, so we go back to source lib. So the nice thing about Rust is like it's got an incredibly powerful compiler, um, which at first like when you start doing is like so painful, but then you realize it's only because you're not very good at programming. And you have to. It's like Rust is like you got to get better, and you're like at first you're like screw you man, I know what I'm doing. I sling Python all day. And then yeah, so it's like it's very powerful compiler, and it's gonna like when you get something to compile in Rust, it feels like you climbed a mountain. The flip side is like while it can feel like it can be frustrating maybe to just like how hard it can be. It does have amazing output. So like this is a great example where like you see how well structured it is. So it tells you like okay in this exact file on this exact line on this exact column your error is here, and then it'll like sure point you to like where the error is, and then give you suggestions. So instead of just like in a lot of languages, like I feel like if this was like a C error, it would be something really cryptic and just like this dump of like this big dump of all kinds of stuff. You'd have like a seg fault, and you'd be like, I don't know what happened. Like I don't know. Um, and can you get a seg? Well, anyway, this Rust tells you, hey, this is the problem, and I think we have a solution. So like the help is like hey, you probably just named it. You probably just spelled it wrong. So try UTC. And then we'll come in here and we'll say UTC, UTC, and we'll try to call the build. And hey, okay, wow, that actually compiled. I mean, we don't do anything. We're just creating some types. We're creating some structs. You'll see. So we got warnings. So Rust will throw warnings if you have code that's not used, and we're just declaring these and not using them anywhere. So yeah, that's fine. That these are all fine warnings. Okay, that actually worked. So then, so yeah, so error. The idea is like the compiler errors are really beautiful and well structured, and then like air does that for like runtime errors. So like if you have runtime error, it'll give it you like really nicely structured errors. Rust error. Try to find like a good image. So um, here's a good example, I guess. So here's this library is called color error. So this is something we'll install next, but you'll see. So you'll get a runtime error, and you'll get these like really nicely formatted um, errors. So it just makes it kind of nice to look at as well. And so we'll add that in too. If you ever use like the rich library in Rust, the Python is like the rich. You can it's really cool. It's called rich. But one thing you can do with rich is you can like hook it into your errors. Like you can like hook it into your logger and like into your error like exceptions whatever. And so when you throw an error, it'll throw you like a whole dump of like um, so instead of just being like something broke, it'll show you like and it's all colored and structured, nice little tables and everything. So it's like so instead of just being like x is not you said like x plus 5, but you didn't ever define x. So it's like x plus. It'll show you like here's where the code happened. Here's like the context, and then it'll show you like you gotta say like here's the state of the system when it failed. It's like this really nice kind of dump of like really nice debugging. Anyway, so that's something we'll probably want. I'm gonna throw in so this cargo add what was it air color air rather. So like, really pretty print these kind of errors. Um, yeah, exactly. So um, let's look at like I'm here. I'm real nice. Sorry, I was looking at trying to find a good example. Um, now I'm gonna we'll install it here. Um, so do cargo run. So if you do cargo run, it'll do the compilation and run for you at the same time. Da, da, da. Okay. Expecting one of what I do here. Okay, so everything worked. So we didn't throw an error, but we should throw. Let me see. It's, yeah. Okay. So let's do air yo man. Okay. So this result type. So by the way, this is there's like a standard IO. Well, I guess there's two. There's like several types. There's like a standard result. I think it's standard. Might just be standard. Yeah, standard result. There's standard IO result. So standard IO result, as you can see, yeah, specialized Rust type for IO. So a result type. Um, so by the way, I don't know Rust at all, but I'm gonna teach you anyway. So that way I can learn. So yeah, so a result is pretty straightforward. It's an enum type, right? Um, so we can make our own. We can say like nim result it takes two. So it takes like it has two possible values. It has two possible types or sorry, two possible variants in the enum, right? The first one is this like okay, and then the second one is an error, right? And really, they type. It's really a generic type, right? So you can see the kind of that's like pushing me here, right? So there's like a type and an error, right? So if it's okay with type T. If it's an error, it's an error with this error, right? So with yeah, these are like keywords in Rust itself. Yeah. Um, so that means basically it's like it's a wrap. It's just like a little wrapper, right? So what makes that nice? It mean it means that like Rust doesn't throw errors. Like it won't just be like I broke somewhere. It returns everything as a type, right? And that type, then you can unpack that type, and you can say, um, so like in Go, I don't know if you use Go at all, but like it would be like func something would take like x as an int, returns an int, and you would say like you know do something with x, or say like y equals do something x, right? And you would say like if be like y air, right? Like if air. I like that it's like switched to Go in the suggestion here. Yeah, return zero, or maybe like return -1. Otherwise, return y. So like in and this is like a thing with more, like newer programming languages. It's like errors as values. Like errors are part of the value itself. So you always have to like in Go. If you didn't do this part, I'm pretty sure it would be a compiler error. Like if you just did this, I'm pretty sure this would be a compiler error. Basically, like you didn't handle the possibility of the fact that do something could break, right? Because it's just some function we don't know what it's doing outside this scope. And then as opposed to like Python, where in Python you say like def do something, right? X is an int, it returns an int, and then so we'd say like or so we call it like something, and then y equals do something x, right? Return y. Now the way this would handle it is like yeah, do something could just break, right? Um, Especially like let's say like uh, do something return z divided by zero, right? So like okay, so this will break. The problem is like this. The problem is like we'll just get a we'll get it'll raise like a value error, right? Or divide by divide by zero, right? Um, and it breaks in here, and like so like it breaks the control flow. It just like crashes the program, as opposed to like passing around explicitly like, hey, this might be broken, this might be broken. Like you got to check for things. So the way you would do that in sort of like kind of defensively program around errors in Python is and like JavaScript and a lot of these other languages. You have these like try zero division error. So you say like okay y equals zero. So this is very similar to what we just did in Go in that dummy example where we said y comma error colon equals this thing and then check for the error. Um, so anyway that it ends up being cleaner to just like pass around these kind of like in Go they're essentially just like tuples of like the first thing is if everything went right, this first thing will be full of something and the error will be null. If it broke, the error is full of something, some error thing, and the result is null, right? And so same kind of concept with the Rust where you define a result and of some generic type T. So this could be a string. This could be an integer, an unsigned 8-bit integer, whatever, right? So just so whatever it is, we wrap it around the OK, and the OK just means basically pass out the value, and then the error just means it's some sort of error. So this seems kind of kind of generic. But what's nice is you can do kind of really nice pattern matching. Um, um, so like right now we say okay, like this. I mean this will break, right? So that won't do anything. Yeah. Actually, won't even compile. Oh, because yeah, let me get rid of sorry standard. So we want the colored error result. Yeah. So yeah. So it found some string here. Um, really, what we want. Oh, okay. Well, yeah. So see this result type. This result type is expecting a type of these parentheses. This is the unit type, which is essentially just like nothing, right? So void, like kind of right. So we expect this function. We expect the output of this function to be basically void, right? Like it's a result. It's good or bad, but there's nothing in it, right? So that's why we basically exactly right. So we could do in here. We'd say like print, um, that's where this would happen, and then now this would run. It says hey name, okay. Um, what I wanted to do was explicitly kind of like throw this error to give you an idea of um, oh I think it has to be sorry like this. Let me see. Oh, error. Okay, yeah. So okay, here's the compiler being awesome again, right? So we just have to say, oh, it's good, right? So it has this like new trait. That's what it's called. So we say error. Here it is. Error new to string. Yeah. Well, let's see. I mean, we might not have to, um, but let's let the compiler tell us if we do. Perfect. Error use of undeclared type error. Okay. Uh, so let me just go back standard. Error. Use. Uh, oh, okay. Okay. It wants me to. Sorry. So it's in standard error. Error. It's a lot. Okay. Interesting. Yeah, this is all good. I love this. So this is like a dynamic. This thing kind of confused. Um, no, I got it. I got it. I got it. I got it. Here we go. Um, I don't know if this. No, let me see. I don't know if any of this will work. Yeah, or drop the second. Sorry, I got. Damn. Okay. Here's what we're gonna do. I'm gonna go back to use. Yeah. So yeah, if you just have like this is it's a string slice. It's a stir. Um, Still very confused about the difference, but there's like 10 different ways to do a string in in Rust. Like this is a string. This is a string. This is a stir. There's like arc, stir. There's all kinds of shit. A string is a string is nice. Like this kind of string, this regular sort of string, right? Is is like a nice UTF-8 8 byte UTF-8. Um, oh god. So the trait is not implemented for. So yeah, so it's not implemented for this stir. So we need to make it a string. Uh, Now what? It's not implemented for string either. What do we need to make it? Oh, um, yeah. Yeah, why is this so goddamn hard? I mean, I'm enjoying it because pain is fun, I guess. Uh, this argument influences the type of air. Yeah. Um, I'm just gonna type in the GPT, see what it says. Oh, okay. I see. Um, so we're gonna add a new. I was gonna add this. I kind of want to add this anyway because I've heard this is a good library. I've heard this is a good library that works really well with air and color air, and I guess maybe it's a dependency now that I look at it. Um, Cargo add air color air. I want to look at the feed. Okay, so cargo add. Yeah, I wanted to look at the features if there was like a feature for it specifically, but there's this thing called anyhow. So then I'm gonna add the feature backtrace here. Okay, so now, so anyhow is like kind of a nice way to, I guess, like deal with errors and results and stuff. Um, so now we say like uh, anyhow. So now we want to use the anyhow result. Okay, so that's how we can throw an error. Uh, okay, now let's see. God damn. Yeah, okay, I see. I see. It wants an anyhow error or anyhow result. You know what, man? This is confusing as hell, and we'll come back to it. Um, yeah, okay. So what we want to be able to do is okay. So we're like okay. So this is like a constructor. Um, yeah. So like implement. So like implement. So where these are like traits, right? Um, so we'd say like yeah, this is pretty. This is kind of boilerplate stuff. Da, 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 da. Okay. So this like allows us to create a new. This allows us to do this kind of syntax, like paper new, right? Um, and then what do we want to do? So like from URL, right? So like from URL, um, URL string. Yeah. So this looks URL parse. This looks like too much. Okay. So what we want to do is let's go cargo add. There's this library called request. This is for what it sounds like requests. Um, basically, but they spelled it with a W, so that way when you Google it, it's like it pops up easier. Uh, so he's calling me. Okay, so yeah, so request is uh, so use sorry, request get. Maybe I just will say like I was do da, da, da. Say from URL. Okay, URL will be a borrowed string, and we'll return stuff. Seems good. I guess. Okay, so request get URL dot. Um, I guess we do unwrap for now. Unwrap is like kind of a dangerous thing. Um, it's not dangerous. It's just like not. We wouldn't use this for production. It's like a way. It's basically a way to just like when you have a result type. Um, when you have a results type, so this will be like basically a type of like result. Probably something like request result or something. Right? But unwrap is basically like just give me the good, just give me the good thing, and if the error happens, just panic and crash. Really, what you want to do is something like you know do this and then say like let some yeah like something like this, right? So a little bit better error handling, but for now we can just kind of do like I guess you just do like expect uh, request failed. Yeah, this is fine. We might have to add like some headers and stuff. Implicitly returns. Yeah, that's fine. That's fine. Okay, so from the response, so like for right now, we could say and uh, Yeah. Oh no, sorry. And here. Sorry. Yeah, this means um, and is a borrow. Okay, so um, the way so this is like the borrow checker. Russ has this thing called the borrow checker. It's their way of having memory management without memory management. Um, so everything is immutable, right, by default. So when you say like let x equals 5, right, right, you can't do let x equals 6, right? It's bound, right? It's bound. You also can't do, you can do like x equals x plus 1, that kind of stuff. You could do that kind of like inside of like little kind of blocks. That's like a different thing, but like you can do it in different scopes. You can like namespace it in different scopes. But like in this, in the same scope, you can't rename something. You can like shadow, it's called. But anyway, so it's immutable. So which gets rid of a lot of nice like problems kind of go away when your data is immutable by default. And so the way it works is like so I can pass this into if I have some function like uh, sorry func um, add yeah agreement, right, exactly. So there we go. So I could easily increment x, you know, so that's fine. That's all good. That's all fine. Um, on keyword let. Uh, um, this is being yeah, whatever. It's fine. Oh, right, right, um, right. Okay. Is that why? Because I have to borrow. I know it's being so weird. Okay, so the borrowing is like I don't know why this is. I don't know what's going on here. Okay, in general, the idea is this, right? Um, you can't. Oh, duh. Okay. Oh, yeah, 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 yeah. So number. Maybe that's why, because I'm calling it x here. That's probably. I'll just say number plus one, right? No. Uh, it's being such a weirdo. Okay, so in general, like probably because yeah. Let me do this one. Sorry, because that like yeah. So I think it's because I can get rid of this now too. There we go. Okay. Okay, so we'll say this returns I32. Okay, so it's because I had in the global, like everything should be, so it wasn't a function, so that let was like being bound globally or something. That's why I was like, this should maybe be a constant if it's like a global. Anyway, okay, so, okay, now, yeah, so now it's like, okay, so now we can do this, and and I like that, like, so Vim is telling me, yeah, this is going to be the I32, so it's going to tell me all that stuff here. Um, so it's just a 32-bit integer, right? Makes sense. Um, so the and right. So the and is like a borrow, right? So in this case, it doesn't matter, but I guess we could say if we did something like this. Let's see. Does that matter? In our case, I guess yeah, it doesn't really matter. But if there were like multiple things that could call this, um, let's see if this does it. I'm not even good enough at Rust to trigger this shit. Uh, yeah. Oh, here we go. So if we put like now, if we do this, okay, const. Yeah, yeah. So constants you need to have. Um, I can't get it to break necessarily. Okay, but the idea is like okay. So imagine we have this number five. We're like we're adding it in a couple of places. We're not mutating it, so that's why that's fine. The and means I'm borrowing it, right? So that's like um, I don't know, you think about like kind of locking it up for a moment. So it's like I'm gonna borrow this thing, and while I do that, nobody else can touch it. But don't worry, yeah. But I'm not gonna change it or anything. I'm just gonna own it for a minute and then give it back, right? I'm gonna give there's like ways of like relinquishing ownership, and then so yeah, when you see this and like the and stir is just like a these from I don't know a ton of I mean I'm not like an expert in C or C++ or any of these things. But it's basically the same idea of like pointers and references and everything, right? Um, so um, that I don't really have like a good hand. Like to your point of if I need to like reference this string in two different places, what does it matter? I don't. The borrowing, yeah, the borrowing. I still don't know. I don't know. Um, I need to figure that out. Yeah, for the most part, it's just like I'll write something. It'll throw, it'll give me a compiler error and say you need to borrow this. I'll be like, yeah, that's okay, that's fine. Um, anyway, the kind of like most complicated thing I have right now is like tabular retriever I'm working on, which is a it's a Rust like HTTP API, um, and the idea is right. So like the idea is you pass in some JSON, and I run some statistics on it. I'm still working on that part. Um, it's got like a health endpoint, right? Some other crap here. Yeah, yeah, yeah. Um, well, I'm using this like this active ActX Web, which is like a really nice framework. Has been pretty awesome so far. Um, but yeah, so this is the most complicated thing I've been doing so far. It's not super complicated. I just kind of started it, but so like in this framework, a lot of the stuff is just like kind of done for you in a nice way. Um, but um, okay, I'm realizing it's quite close to one. I have to go to a meeting soon. Do you want to call it for a day? Because at this point, um, okay. Um, yeah, I think like after like one or so in the afternoon, I'm free. I think. All right, let's end this stream here. We got throw the ending stream